Thanks, everyone. Thank you, Julian. My name's Daniel Dunne. I'm the Health, Safety, Environment Quality Manager for Paynters. We operate across the eastern seaboard of Australia, employ approximately 200 plus employees across a number of sectors, which you can see there, approximately 27 major projects on the go at any one time. The reason why we've come on a journey as painters is the common issues that we find on all our sites, and I truly believe that it's come from the level of competency that we don't have in the industry anymore around scaffolding, which has now led to builders having to inspect scaffold and having to be more competent to check the scaffold. These are the common issues that we find. The drawings, which I'll go into more detail, loadings on scaffold, catch platforms, lap boards, ties, mix and match scaffold is a big one. Containment screening, sole boards, bracing, internal gaps, bottom ledges. I'll cover some of those in some of the key ones during my presentation this morning. Our response to the issues was to develop and deliver training to our staff, both internally and externally. All of our project staff, from project manager and construction manager downwards, undertake internal scaffold training, which is partly of what I'm going to show some slides from that today. And then externally, our site guys, our supervisors and health and safety advisors on site also undertake high-risk work licence training, not to erect scaffold. They'll never do that in their lifetime with painters, but just to give them their technical awareness so that when they are communicating with scaffolders, they can communicate in the right terms with the scaffolders. And it's also led us to the development of tools for the project teams. And I ordered a scaffold inspection template, which I'll show you a few slides of as we go through. Internal training is done annually. We cover licensing, so that project teams know what level of license required for what scaffold, legislative requirements, and the components. Very important for me that our project teams understand the terminology of the components. The plans and design is probably the most important thing for us as a company, because builders are competent at reading drawings. They may not be competent as scaffolders, but they are competent at reading drawings, and we can get the right detail in the drawings, then it makes it a lot easier for our project teams to identify non-conformances with the scaffold. Common issues, and then external training, as I mentioned. Their plans, I can't emphasise enough on how important it is to have site-specific plans and not generic, even for basic scaffolders on site, and the requirement to internally and the emphasis on reviewing those plans prior to the contractor starting on site. If you don't have plans before they start, which we've all probably been in that situation, it will never match the plan. They'll start basing out in the opposite corner, the bays won't line up, ties won't line up, and everyone ends up in a world of hurt. If you can't get the first lift right and the base right, then the rest of the scaffold's going to follow that. Elevations, I still see it every now and then where an elevation will come through generic. But if we're talking about multi-level buildings and roof work for scaffold, the design is the most important thing, because if we don't get the floors right, we're going to end up in a world of hurt as we go further up the building. If we're using the scaffold as a catch platform, also could be in a world of hurt by the time we get to the roof line. If the drawing's specific enough and got enough detail, it'll make it a lot easier for your project teams to identify non-conformances. You can see the drawing there shows ties, shows bracing, shows the stair locations, has detail. The more detail, the better. As Julian mentioned, the Queensland's Code of Practice was released earlier this year. It has been updated and has a table in it, very good table to identify what's a competent designer and when you need that designer. I've got an example here of some engineering approvals. We had a project about 18 months ago where the project team, the scaffolders, designed an edge protection system for a project. By the time it got to my desk, it was already half erected. I questioned the design. It was relying on compression. You can see the detail in the section there. I was relying on compression fitting of screw jacks in a window reveal as the primary source of securing the edge protection with mesh on it. So we had additional wind loadings into the building. What I'm trying to emphasise here is the fact that you need the right engineers. You need to have the right team with the design and the installation. So this design was signed off by an engineer. You can see part of it on the screen there. We then raised the question that we wanted an independent engineer, not the in-house engineer. We got a second engineer, which for the life of me, I didn't think we'd ever get a second engineer to certify it there, but the scaffolders did. They got an external company. One of the notable points here is that the standard dates are incorrect. They'd been revised. At this point, we then went for a peer review. because there was a dispute between the scaffolder and ourselves on whether it was compliant or not. We went for a peer review. I got an email back straight away stating not a chance this will ever comply. This is it in situ. That hadn't been used at that point. And we had exclusion zones below it as part of the construction site. At 11 o'clock that night, I got a phone call, and this is what the project team found at 11 o'clock. Obviously, the photos taken during the day, but the whole one elevation had let go. There was no additional wind load that night. We checked all that. There, just from the expansion and contraction of different materials, timber, concrete, metal, it had loosened and fell out. To make this safe again was a whole nother world of hurt for everybody involved to try and make it worse without a catastrophic failure. I just want to emphasise the fact that you need the right engineers and the right team. Not all engineers are experienced in temporary structures, and some may not specialise in scaffold either. So really do your research and get the right engineers involved. Ties is probably one of our biggest issue we find on site. You'll probably find most of your scaffolders have tie designs. So the standard calls for double leg ties. The only time you can deviate from the standard is when you have a design. So really have a look at the design, because the design is usually correct, but it's the scaffolders that actually don't follow the design on site, and they must have a check coupler on them. And typically they've got to be within 300, a single leg tie must be within 300 of a node point where your transoms and ledges intersect. Continuous bottom ledger is another one that we commonly come across. Again, referring to the design, should show where ledges can be removed. And typically a ledger can only be removed when it becomes an end bay and you've got end bay bracing in there, as you can see in the detail. And then when you have a return bay, you should see a butt tube going across, tying the two ledges together, and then again at every 2 meters. As you can see, both those pictures there are non-compliant. The walkway does not have end bracing in it, and the return bay has a tie at the bottom, tying the two standards together in replace of a ledger. It doesn't have it continuously up the scaffold. Alignment with floors. As I mentioned earlier with the design, again, just emphasising the fact to review your design. If you get to the first floor and your alignments are out, you're going to be in a world of hurt every lift after that. By the time you get 4 or 5 lifts up, it's irreversible, apart from pulling a scaffold apart. There is detail out there in standards which will determine maximum 225 out and then 300 either down or up from the concrete structure. As you can see there, once you exceed that, then you have a huge gap. That gap in that picture was probably about 600-700 mil for someone to fall through. What we've done for our project teams is developed an inspection criteria through iAuditor. As everything, we review this in part of its life cycle. There we've determined what level of documentation we want to assist our project teams, and they'll typically go through this at the handover stage, and then again periodically through the scaffold. As I mentioned, we're always making modifications to it. One of the modifications we've made is that scaffold can be very laborious to inspect for a builder or a safety advisor on site when you have numerous lifts. And what we were finding was that might do the first lift, but then not the next lift and document it. So we've now created a function in there where our project teams can add additional lifts, and then the smart questions behind there will only be relevant to each lift. So you don't have to look at all the documentation, bearings and everything else associated with the additional lifts there. So we're ever developing this and releasing it out to our project teams. Thank you, everyone. I'll now hand over to Geordie.